All right, ladies and gentlemen, let's take a look at lesson 6.3. And what we're going to do is we're going to show that quadrilaterals are parallelograms. So that's our goal, to show which quadrilaterals are parallelograms. We looked at properties of parallelograms in lesson 6.2. And so now we're going to work on recognizing some more properties and using those properties. So let's take a look at what today's lesson is going to look like. We're going to start off with the theorem. Once again, I want to tell you it's not so much that it's theorem 6.6. There's nothing magical about that number. What it is we want to take a look at what are they telling us in this theorem. So what the words mean is if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Let's try that again. I must not have backed it up. Are a parallelogram. All right, so we see this oftentimes. We talk about special things like, oh, rectangles have opposite sides that are equal. Squares have opposite sides that are equal. But there's other things we need to know about a rectangle or a square. So the first thing I can start with, if I know opposite sides are congruent, if opposite sides are equal, then it's a parallelogram. So what that means in symbols is if PQ is congruent to SR and QR is congruent to PS, so we see our congruency marks here, then PQRS is a quadrilateral. I'm sorry, it is a quadrilateral. It's a parallelogram. All right, so that's what we're looking at, trying to identify which things are parallelograms. They now throw another property at us, this theorem 6.7. If both pairs of opposite angles of a quadrilateral are congruent, so we have opposite angles congruent, then the quadrilateral is a parallelogram. A parallelogram, ladies and gentlemen, is this beginning quadrilateral. That's kind of the basis. It's the parent of what I would call of all these other ones that we know so well, rectangles and squares. And so what it means in terms of symbols, if angle P is congruent to angle R, so our angles, even though we're in quadrilaterals now, not triangles, we still use the same symbols. So congruent angles still are shown the same way. So P is congruent to R, and Q is congruent to S. We have to have both pairs being congruent. Then PQRS is a parallelogram. All right. So the follow-up, it says write the converse of theorem 6.6. Is the converse true or false? How do we know? So converses, we're going to be doing some review. This is we switch our hypothesis and our conclusion. Remember, we have an if-then statement. In the converse, we do the then the if. So if we do a split screen here and we take a look at what that is, I'm making some of you dizzy here. All right, so let's go take a look. Theorem 6.6, it says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Well, I got to start with my then. So I say if, we're going to go back and do this, if the quadrilateral is a parallelogram, so if the quadrilateral is a parallelogram, quadrilateral is a parallelogram, then, now this is where my if comes in there, my hypothesis, then both pairs of opposite sides of the quadrilateral are congruent. Then both pairs of opposite sides are congruent. So, all right. Is it true or false? How do we know? Well, it is true. And the the reason we know that is we learned that in lesson 6.2, I believe. I want to check that. Lesson 6.2. That was our very first theorem. So this was our first parallelogram theorem. And the book called it 6.2. Like I said, there's nothing special about that number. This is just how our book has organized them. But we know that this is true because we started out. That was how we were recognizing them in our last lesson. All right, so now we have to write the converse of 6.7. So the converse of theorem 6.7 would be if a quadrilateral is a parallelogram, then both pairs of opposite angles are congruent. So is the converse true or false? It's true. And for the same reason, we learned this in lesson 6.2. And they actually call it theorem 6.3. So we were learning properties in lesson 6.2. We learned that opposite sides are congruent, opposite angles are congruent. We learned that consecutive angles are supplementary. Now what we're going to do is take a look at, okay, what if I don't know that it's a parallelogram? If all I know that this is a quadrilateral, how can I go back to a parallelogram? And that's what lesson 6.3 is. It was taking something that you're not sure what it is, using measurements, using relationships that you see on that quadrilateral, and concluding that it's a parallelogram. All right, so how do we use that? So tell whether the quadrilateral is a parallelogram, or if the quadrilateral is a parallelogram, explain. So when I look at A, I see that I've got congruent sides, but those aren't opposite sides being congruent. And so I'm going to say no, the quadrilateral is not a parallelogram because it has two pairs of congruent sides, but opposite sides are not congruent. All right, opposite means they have to be across. They do not intersect. They do not meet at an endpoint. All right, if we look at B, what are some things that I noticed? Well, I noticed 140 and 140, so that means congruent angles, and they are across from each other. If I look at my second pair of angles, I've got 40 and 40, so yes, I have both pairs of opposite angles being congruent. So yes, the quadrilateral is a parallelogram because both pairs of opposite angles are congruent. Now notice, ladies and gentlemen, I start abbreviating, and this is about where your abbreviations can end at. You need to tell me that they are opposite angles, so I should see opposite angles. I need to know both pairs, and I need to know that they are congruent. So don't just tell me angles are congruent. I need to know that both pairs of opposite angles. We need to make sure we're getting all of it in there. So write this down the way I wrote it, and use that as you're going through your homework. All right. Now we're going to jump into two more theorems, the last two theorems of this lesson. It says if an angle of a quadrilateral is supplementary, so once again, this sounds real familiar, to both of its consecutive angles, then the quadrilateral is a parallelogram. So what is that going to look like? So what that means, if we take angle P plus angle Q, and it equals 180 degrees. And then we take angle Q plus angle R, and that equals 180 degrees. So we have to check this angle Y with both P and R. So if both of the consecutive angles add to a given angle, and it equals 180, then it's a parallelogram. Theorem 6.9. Once again, these are all looking very familiar. We're just, like I said, being able to take things that we see and put them into a parallelogram. So if the diagonals of a quadrilateral bisect each other. So sorry, I don't have enough room there, guys. So if the diagonals of the quadrilateral bisect each other, and I see that I have that because PM is congruent to MR, that diagonal is cut in half, and QM is congruent to MS. All right? So if QM is congruent to MS, and PM is congruent to MR, this is what it looks like in terms of symbols in the diagram, then we have a parallelogram. So for the follow-up here, we want to write the converse of theorem 6.8. Is the converse true or false? And how do we know? So theorem 6.8 says, you know, if consecutive angles are supplementary, then it's a parallelogram. So we're going to start with if a quadrilateral is a parallelogram, then an angle is supplementary to both of its consecutive angles. So is this true? Once again, yes, this is true. Because we saw this in lesson 6.2. This is one of our, I believe this was the third property we had of parallelograms. And so this was theorem 6.4. And so once again, guys, I just want to reiterate, it's not about memorizing these theorems. It's about recognizing these relationships, knowing to check diagonals to see if they bisect each other, and they both have to be bisected. Checking those consecutive angles are supplementary, so both to the left and to the right of a given angle have to add up to 180. Checking that both pairs of opposite angles are congruent. Checking that both pairs of opposite sides are congruent. Doing those, looking for those four relationships allows us to show that we do have a parallelogram. So let's take a look at that. So now we're going to use theorem 6.8 and 6.9. So tell whether the quadrilateral is a parallelogram. Explain your reasoning. So if I look at A, I have one pair of opposite angles. I don't have another one, so I can't use opposite angles being congruent. But what I can do is I can take this 95 and compare it with the 85. Now I only have to add it one time. So if I look at this, 95 degrees plus 85 degrees does equal 180 degrees. So the answer is yes, because an angle is supplementary to both consecutive angles. And so you can abbreviate, we could abbreviate supplementary and angles in there, but that's what we're looking for. If we take a look at B, I've got 2 and 3 not congruent. And then we need to look at this. 4 and 3 also aren't congruent. And so no, it's not a parallelogram because diagonals do not bisect each other. All right, ladies and gentlemen, this is kind of where I'm going to stop. You're going to do checkpoints on your own. I might do one of them with you, but I want to stop and explain to you. It seems like throughout the year, when it comes to explaining, you guys struggle with, well, what does it mean to explain? You need to keep example 1 and example 2 out while you're doing your assignment here in lesson 6.3, because these are the explanations you're going to use. It's either yes, it has this, or no, it doesn't. But you're looking for diagonals bisecting or diagonals not bisecting. You're looking for supplements or you don't have supplements. If we look back at example 1, you either have opposite sides that are not congruent or opposite sides that are congruent. You have opposite angles that are congruent or opposite angles that are not congruent. But you're going to use one of these four explanations with your yes and no. So let's take a look at the, we've got checkpoints. I've got 3 given angles, so tell whether or not it's a parallelogram. Well, when I look at this, I'm going to look at 60, because 60 is in the middle, and 60 plus 80 equals 140, which is not supplementary, so it's no. Consecutive angles are not supplements. So once again, there's our explain. You've got your explain, your reasoning. Here, if we look at number 2, we're looking at diagonals. So you should tell me something about diagonals. Either yes, they are because they bisect, or no, they don't because they do not bisect. 3 is sides. So you're either going to tell me opposite sides are congruent with a yes, or no, both pairs of opposite sides are not congruent. And then 4 gives you angle measurements with congruency marks. So it's either yes, both pairs of opposite angles are congruent, or no, both pairs of opposite angles are not congruent. But these are do now on your own. These are do now on your own. All right, I hope you guys have a great evening, and we will see you in class.